The most recent Bellows units I've been making, I've been using these L289N. These are the red units. To wire all these up, you need to make a harness that comes in with 12 volts and has leads that go to the motor controllers and then to the barrel jack on the ESP32 Wemos D1. Now in the program that I'm writing, I have three outputs. One goes to the front, which I am using as the on the top of the wood stove I'm using. I have to have a separate fan for the front because it's got vents on the front. That's wired to pin 27 of the ESP32. 26 is the primary fan. Now I use it as the secondary fan. However, it gets the modulated signal. And I run 75% of that to the front fan. Now the convection fan is different in that it is going to a separate fan that turns on based on a temperature signal. So it turns on lightly when the stove is warm, much more strong when the stove is hot. Then as the stove cools down, it decreases as well. So it's not the same as a combustion air fan. A convection air fan is to spread the heat through the room off the stove. So wiring, I have the pin numbers that you have to, and it's only one wire that goes from that pin to that those two internal pins on the board. I always wire them up so that red is toward the power. So your 12 volt out has a red wire that goes toward the power side and toward the logic inputs. And it's the two center pins that I'm using. And that works great. These L289 ends don't put out a full 12 volts, but other than that, they're very reliable motor controllers. This is the RGB LED. I like to use it in both the bellows and in the display unit. It is wired using the ground, the 14 pin for green, the 12 pin for red, the 13 pin for blue. It'll work off the ESP32 3.3 volts. I'm still working on the code that drives this. However, if it's wired up correctly on the board, it will illuminate red when 20% opacity is exceeded. This is the wiring diagram for the display. The display is used in both bellows and receiver units. It requires 4 wires. One, I like to drive it off the ESP32 board. So we have 5 volt and a ground. 5 volt goes to VCC on the display. We also have SDA and SCL that have to be wired up. This is an I2C device. It works very well. You just got to get it wired up correctly. And oftentimes you don't, or I don't, and it doesn't work. The thermocouple, or stove temperature sensing device, is a thermocouple, type K thermocouple. And that's about the trickiest thing to wire up. Positive in thermocouples is never red. And so I color the positive terminal black, and I always put the positive terminal on the black side. You have to hook up 5 wires for this because it's an SPI device, and it uses 5 pins. You need the 5 volt ground, 5 volt and ground. You need an SCK, a CS, and SO, and all those pin diagrams are listed out here. I'll list them. SCK is 19, SC is 5, SO is 23. These are easy to mess up. However, I got them listed here. If it's working, you'll get temperature out. This is not used with a receiver module. It's only used with Bellows units. This is a prototype I've been using for 1 or 2 years. It doesn't have a display. It's running the algorithm and does a great job. Has about 2 hours of battery backup on it. Is charged by a USB cord and runs a fan for my low-pi Revere quite well. In fact, I just haven't taken this off because it runs so nicely. It has a thermocouple input and motor controller built in. It does not have a display. This is a display prototype. I've been using it for some videos. It's not hooked up right now. However, it's really nice to make these things on a board where you can actually reach in and disconnect and connect things. This is the prototype that I've been working with for the past few weeks. It helps to make them like this because you can reach the components and such. 2 L289s, a Max 6675, the display, and the ESP32 Wemos D1 right there in black and center. Everything's hooked up and working on this one. I've recently done some tests and I'm satisfied that the algorithm's working correctly and it's communicating with the Octoring. So I wanted to put it in a box, but you start here before you put it in a box. Here is the latest revision of the prototype. It's in a box. I'm going to test this out for a while. This is what they're going to look like this year. I simply have to machine 2 pieces of wood and 2 sides. All the wires come out the back. And it's a work in progress. However, the display's working, the thermocouple's working, motor controllers are working, got 3 channels, and the RGB LED is working. So I feel this is a good point to stop innovating and make this thing work. It communicates with the Octoring. You can see that it's reading out a 1.18 opacity and a 490 nanometer color. So this is what I'll be testing next, and this is kind of what I've been working up to. We are Smokeless Chimney. You can find us at www.smokelesschimney.com. We're on Facebook, Reddit, and YouTube. Thanks for watching.